Thank you, Mr. Toastmaster, fellow Toastmasters, almost Toastmaster guest. Good afternoon. My name is Michael Hernandez. I'm with HBM. How may I assist you? 8 hours of the day, that's a response you'll get when you give me a call. What do? I work in the pool of science known as test and measurement. It has to do with metrology, the measurement of things. A good example to start things off is, do you know how much you weigh? Maybe. Do you know how much you really weigh? No. We can never know the true value of a thing, of a weight, or of a voltage. We can only take an estimate within a range. We will never know an exact, I weigh 185 pounds, 175 pounds. Not that fat, 175 pounds. Unless you have a stone or something that you know is 175 pounds. But that stone, how do you know it's 175 pounds? Okay. So I work in the field of comparing a known value or an unknown value to a known value. And it might not be applicable to everybody in this room, but let's say you're a design engineer. Let's say you're a prototyping engineer, a validation engineer, a product improvement engineer. All of these engineers want to make a modification to a design and understand quantitatively how it improves the performance or takes away from performance. So I don't want to dive too deep into the water and be too elaborate. So I'll take the lead of one of my mentors, my current boss, Walt Farchman. He is a sales manager for the U.S., and I've been working for him for 2 years. And he's a great guy. I trust him with my life. I really do. And I'm going to take an approach that he did when he onboarded me and just take things at a high level just to get things started. So let's start with the agenda. We'll be talking about sensors and data acquisition systems, and then analysis. So sensors, how do we begin? How do we measure a thing? How do we say with confidence it's around this value? Well, most of the, this is lingo, transducers in our world are based on the principle of strain gauges. Strain gauges are tiny little resistors, and if you haven't taken an electrical engineering class, when you have a circuit, everything must equal out. You can't have a power source that's above the load-bearing unit. It just will explode or burn the unit, cause a short. So the way we use these strain gauges is we create a Wheatstone bridge in which every leg of the bridge is equal. And I left some of my materials at home, but one of the founders of the strain gauge, or developers, is his name is Carl Hoffman, and he wrote an introduction to stress and strain analysis using strain gauges. And he goes into what is known as the Wheatstone bridge, that cube that I just mentioned. And the idea is that if you know that 3 of the legs are 350 ohms, if all of them are equal, the voltage in and the voltage out should be equal, right? Now, if you change some of the resistance values, then the voltage out is going to change a little also. So you can correlate that voltage difference to a physical value. And so with that principle, you can either put on a strain gauge, just a strain gauge, onto an article, and then when you bend it, that difference in the surface is going to correlate to a change in resistance on the strain gauge. So that's a simple way of putting it. And then, not everybody has, it takes 45 minutes just to learn how to lay a strain gauge. Now imagine putting one on. So let's say you're a prototyping engineer. You don't have that time. You just want to know quick and dirty, if I sit on this 100 times, when will it break? On the 80th time, 100th time, at what load? So they take that concept and they put it into a metallic housing. And when that metallic housing deforms, just like the surface, we know that that can correlate to a change in strain. Okay. So different types of transducers out there. Some of them are thermocouples, which are just two copper or different types of metals, and when they come into contact at the tip and you change the temperature, there's a change in voltage. So that's how you will take in measurements. Some sort of voltage, and we'll just translate that to a physical value. So the next step is, okay, there's a voltage there. How do we capture it? Well, depends on what your application is. Are you going to be working outside? Are you going to be working in a lab? Are you going to have 4 sensors or 1,000? This will affect your sampling rate, which means, if you're seeing a signal and it's bouncing up and down, if you don't sample fast enough, you might get an aliasing effect, which means it looks like another type of signal. So you want to sample fast enough to where you can clearly define what your signal looks like. So there's different types of systems out there. This is just an example of a lab system, and this one is a string gauge amplifier, so all of the main technologies can be read in. And the important part here is to make certain that the sampling rate is met, your excitation voltage is matched, and that you have a way to capture the data and store it. Okay? So then after you've captured the data and you want to look at it, we get into analysis. When you get into that portion of the project, you're on your own. But a lot of systems will have built-in functions. So all the math and physics and engineering you did in college, you no longer have to sit down and write through. There's just a button you just touch, and it'll give you the root mean square value or whatever you need. So it's a deep world. We're just diving along the surface, swimming along the surface. I'm not Michael Phelps, but I can definitely compete in this arena. And so I just wanted to give you a high-level introduction to the world of test and measurement. So if you wanted to create a product, you know where to start. Thank you.